Good morning. Today we are talking about the dosage of urinary formic acid using an exclusive kit for this specific analysis and using a gas chromatograph combined with a mass detector. Why is formic acid dosed? Because formic acid is toxic to the body and can cause disorders, including visual disturbance due to papillary edema, metabolic acidosis, optic neuritis. In reality, in the field of occupational toxicology, formic acid intoxication may be due to the exposure to solvent methanol. In fact, methanol is widely used by industries for the production of cellulose, synthetic resins, formaldehyde, acetic acid, and fuels. The most common way of exposure is respiratory. The greater toxicity of methanol is not due to the molecule itself, but to its formic acid metabolite. Methanol is initially metabolized to formaldehyde through alkyl dehydrogenase. The subsequent oxidation of formaldehyde to formic acid occurs by means of the aldehyde dehydrogenase, an extremely rapid reaction, so that in patients with certain methanol intoxication, it is not possible to dose formaldehyde either in tissues or in biological liquids. Methanol dosage is only useful if it carries out earlier, while the dosage of the formates has a great utility and can be used as an index of severity of intoxication. Also, the exposure to dichloromethane in industries used as solvent, degreasing agent, and to remove paint can cause an increase in urinary formic acid, as its metabolism includes two ways. In one step, cytochrome P450 leads to the formation of carbon monoxide, CO. In the other way, one has the formation of formaldehyde, formic acid, carbon dioxide. Now let's begin to illustrate the method for determining formic acid in urinary matrix. What do you need for this analysis? GCMS medium level with headspace, ready-to-use kit with calibration standard included, micropipettes and variable volume tips, vials for headspace, caps for vials, HPLC grade water, vortex, urinary samples collected at the end of the shift, installation and conditioning of the gas chromatographic column VF5MS 30 meters, according to the specification reported by the manufacturer. Let's take as an example an analysis session of 7 urinary samples on which to perform the dosage of formic acid. Together with these samples, we will also analyze one urinary calibrator, which we will use to automatically build the calibration curve on the software, and 2 controls, level 1 and 2, which we will use to check the calibration curve's validity, and therefore for the whole analytical session. We prepare as many vials as the sample, plus the calibration standard and the controls. Dilution of the calibration standard solution to 73.2 mg per liter should be done by dispensing 1980 microliters of HPLC grade water and 20 microliters of reagent C solution test chemically standard into a test tube. Dilutions of the control standard solution at 36.6 mg per liter and at 146.4 mg should be done by dispensing into 2 tubes, 1990 and 1960 microliters of HPLC grade water and 10 and 40 microliters of reagent C solution tests chemical standard respectively. It is important to underline how such standard calibration and control solutions are prepared for each analytical session. We proceed with the preparation of the calibrator, the controls, and the samples. We dispense in vials of 10 ml for headspace 1 ml of a known urine sample, 1 ml of calibration standard, and 1 ml of each standard controlled solution. Next, we add to each vial 20 microliters of reagent D, standard internal solution. Immediately afterwards, we dispense 1000 microliters of reagent A, dilution solution. And finally 2000 microliters of reagent B, derivatization solution. We close the vials hermetically with the help of a crimper and vortex for 5 seconds. At this point, you leave it for 20 minutes at room temperature. In the meantime, we move to the gas chromatograph and activate the instrument method, Eureka kit formic acid, so that the system sets itself to the correct flows of temperatures. The machine on which we perform these tests is a gas mass 4000, but keep in mind that the methodology can be applied on mass gas model with headspace. Next, we place the vials in the autosampler tray, starting with the calibrator, continuing with the 2 controls and the samples, and start to acquisition in the automatic mode. The chromatographic runtime is about 10 minutes. And for our sequence of 7 samples, you will have the results including injections of the calibrator and 2 controls in a couple of hours. This is a typical chromatogram in which the peak of the formic acid comes out at 1.39 minutes and the peak of the internal standard comes out at 1.32 minutes. The time taken for this analysis is as follows: 30 minutes for the dilution of the chemical standards and the preparation of the samples in the vials, 20 minutes for derivatization, approximately 100 minutes to analyze all the samples. In these conditions, we are able to report in the morning and use the instrument to perform other analysis. Ultimately, this use of the Eureka kit for the analysis of formic acid allows you to obtain sensitive and accurate results, provide appropriate reports, take full advantage of your equipment. Shortly, we will send you the method where you can see recovery of the method equal to 100%, a wide range of linearity from 1 to 1000 mg per liter, CV inter and intra series less than 5%. Currently, the Eureka kit that I presented is the only ready-to-use kit on market for the dosage of urinary formic acid in GC and MS. And now, let's briefly summarize. In this video, we have highlighted the importance of determining the level of formic acid in urine in occupational toxicology, seen the simplicity of use of the kit for the analysis of formic acid in urine, shown the performance of the method in terms of analysis execution speed, reliability, linearity, accuracy, reproducibility. Please do not miss the next video. We'll talk about another Eureka kit that might interest you. Goodbye and see you soon.